Today we will be taking a look at the challenge Baby Heap of Hackendyne CTF 2023. Let's just download the challenge binary. We can see in this challenge, it is pretty similar to the challenge called Malloc Boy, Struck Boy, sorry. Uh, this challenge. Uh, so in this challenge, there is a chunk, uh, and here we are using malloc. Malloc basically is an instruction which allocates memory on the heap. Heap is one of the memory regions that is present in the program. The various regions are mainly stack, code, heap, and data. So heap is one of them, and malloc is used to uh, allocate memory on the heap. So here we are allocating some memory. We are allocating 20 memory of 20 size initially, and then memory of size 38. Later we are getting like input. We are getting the input in this thing point, and we are setting the pointer. We are just setting this thing as equal to a new chunk pointer as a new chunk, and then if in this chunk the forward and the backward pointer are respective, then we can get the flag. So the main purpose of this challenge is to explore the heap section. So I will be using pond debug in this challenge, as it is with heap. Pond debug helps us quite significantly. Hmm, let's just disassemble meme, and set a breakpoint after. Like here we are getting, like here this is the gets, like here we are getting the input. So let's just set a breakpoint over here. So b star and the address. This will set a breakpoint. Now let's run the program. Okay, want to see something? I will see. And we can weave the heap using the whisk command of pondebug. As we can see over here, uh, the input which we gave is sent on the heap. Now, an interesting thing to note that uh, here we are using gets, so there is no size check on the input. So this here is an example of heap overflow. So in this thing we want to do is to set this address, this chunk as proper values with proper FD and BK. So what we will do is just try to understand what is happening first. That will give us a clear idea. So first we are getting the data into pointer 1, and we are doing operations on pointer 2. As we can see, this is the first chunk and this is the second chunk. Don't worry about the size. Malloc actually allocates this size is actually 0x20. Don't The one is something known as prev in use bit. We should not worry about it as of now. And malloc always allocates chunks in the size of in the multiples of 16. So if we here it is like 0x 14, which so it will try to allocate just bigger than 14, 0x14, which is 0x20. just bigger multiple of 16, which is 0x20. So the size of this chunk is 0x20. This is obviously this is the prev in use bit. And similarly, the size of this chunk is 0x30. So now let's overflow it. Run it again. And let's just send some more data. Okay, it crashed. Uh, it crashed and oh, okay. This thing crashed because there is something known as top chunk, as we can see over here. Uh, so this is our first chunk, initial chunk. We overflowed it and rewrote the size of the second chunk. That's the problem. So a very huge chunk was malloc is thinking that this is a very huge chunk, and then again these are some values on the chunk. And as you can see, the size of the top chunk is changed. When the size of the top chunk is changed, we get like it is not allowed to do. We are not allowed to change the size of top chunk, and as a result, the program crashed. Generally, if there is a heap overflow, the program won't crash. That is one of the problems with heap. That's why there are many memory leaks as such. Say when we say memory leaks, obviously the first thing that is like heap leaks are quite common. So let's just run it and this time give some less input. hmm. As we can see, this time it did not crash. Here is the top chunk and here is this chunk. So we need to set the value. This thing chunk pointer will point to ptr address of ptr minus 10. So PTR starts from here. So PTR minus 10, 0x10 would be this thing. So this value needs to be some prev size, and this value is prev size. Then this value will be like the current chunk size, and this value will be the FD and BK pointers. So let's just set the FD and BK pointers so that they are equal. So again, we will be using pawn tools for this purpose. Now let's just count how much we need to overflow. So first we need to overflow this thing and this thing. This is zero. This is like this is 8 bytes. This is 8 bytes. So 16 bytes over here, and this 8 bytes also we need to overflow, and here we need to write what was the previous size so that this like there is no error of chunks. So let's just it was initially 0x31, so let's just set this thing as 0x31. This thing needs to be uh, FD needs to be cafe babe, so this thing needs to be cafe babe, and this thing dead beef. Let's try it. So first 16 bytes, first 24 bytes should be some garbage. Then we should set the next thing as 0x31. Then we must set it cafe babe plus P64 0x dead beef. And 3 Okay, so as we can see, we got the shell. This was the challenge. Uh, the purpose of this challenge was to teach you about heap and how memory is allocated on the heap and how this conversion, this thing happened. You need the main part of this challenge was for you to understand this thing and about the heap, basic knowledge about the heap. That's all for the challenge. Thank you.